Here we go. Because of the Pythagorean theorem, let me do this. Yeah, okay. Because of the Pythagorean theorem, we can now describe this triangle. So really quick, okay? Oh, hello. All right. Over here, let me draw the picture. If you were to take any angle, yeah, okay. If you were to take the angle at any point, right, you can drop that point down to the x-axis, like so, and make a, what kind of triangle? It's a right triangle, right? Yeah. Okay. Now, instead of A, B, and C, we're going to do X, Y, and R. Yeah, there we go. Yeah. The R, if you think about it, so this ray could go around and around and around and around, right? The R, since it goes around and around and around, R stands for radius. So R just stands for radius. Yeah. And in the triangle, the radius is the hypotenuse. Okay, so that's kind of like your C. Right. Okay. Now, that coordinate makes that triangle. So this length right here, how tall that is that the X or the Y? This is the Y. Exactly. And then how far along it goes on the x-axis, of course, that's the x. And if that's the angle that you're looking at, you're actually looking at this angle inside right here. So let's call this like theta prime, like so the second part of the angle. Right? So to solve this triangle again, it's still Pythagorean theorem because any triangle on the coordinate plane can be made into a right triangle. Yay? Okay. So instead of a squared plus b squared equals c squared, it's r squared is equal to x squared plus y squared. Yay? Okay. And to solve for the radius, just take the square root of x squared plus y squared. Does that make sense? Sure. Just nod your head so she'll continue. All right. Here we go. All right. This brings us to the following. All right, so we got that x and y stuff, right? Okay. In geometry, we learned the three-letter word SOHCAHTOA. Okay. Oh, that's an A. That's an A. Sorry. All right. Ms. Holmes, have you ever heard of this? Yes. S stands for? Sine. Very good. This stands for sine is the opposite over the hypotenuse. C is cosine, adjacent over hypotenuse. And then T stands for tangent, opposite over adjacent. Does that look familiar? Okay, it's coming together. It's coming together. Here we go. That means if your angle is right here, right? If your angle is right here, forget this one. If your angle is over here, then your sine will be the opposite over the hypotenuse. In x, y, and r terms, what is opposite to theta at this point? The y. And what's the hypotenuse? R. Right? So sine would be y over r. Cosine is the adjacent one. X over r. Very good. And tan is opposite over adjacent. So y over x. Oh my gosh, my page. Here we go. Yeah. And that brings us, here we go. That brings us our 6 trig functions. Right? X, y's, and r's. That's it. Sine is x over r, sine is y over r, cosine x over r, tangent y over x. Yay? If you have a hard time memorizing it, because you have to memorize this, okay, the r is always the denominator for sine and cosine, true? Yay? Okay, here we go. Sine and cosine in alphabetical order, cosine would come first and sine next, right? Cosine is the x and sine is the y. Yay? Also alphabetical order. So alphabetically, these two go together and these two go together. Yay? All right? Then as far as tangent goes, it goes the y over the x. Later on when we talk about Tropical Smoothie Cafe, it'll help you remember it even better. But for now, you have to memorize those three. Okay? Yeah, you know sine over cosine. All right, here we go. Now, those three have a flip, the reciprocal of them. The reciprocal of them also have names. Now, some of the names are pretty easy to remember. For example, the reciprocal of tangent is cotangent. To do cotangent, you would just flip this. So it'd be the x over the y. Yay? The other way around, though, the secant and the cosecant belong to the opposite of what you would think, right? For example, secant starts with the letter S, correct? But secant is not the opposite of sine. It's not the reciprocal of sine. It's the reciprocal of cosine. And cosecant is the reciprocal of sine. So the S's and the C's switch positions. Okay, repeat after me. Cosecant.
Cosecant.
And this one is secant. Very good. Question: can George Washington become a country?
Yes.
Cosecant. All right, here we go. Right. Okay, so you have to have these trig functions, right? And you have to have them memorized, all right? Memorize those trig functions. If you can only memorize the first three, that's fine, because the other three are this way. Okay? Yep. Okay, here we go. It's probably the simplest one. Because when we do this a different way, when I show you the identities that go with it, if you want to just revert back to X, Y, and R, I won't stop you. Okay? Because it's just pretty simple. All right? Here we go. Anyone still copying? You still copying? Okay. All right. Woo! Let's do some math. All right. Ms. Zara is probably just like, oh man, can we move forward? You love it. I love it too. All right. Here we go. Test question, right? Once upon a time, the terminal side of an angle theta in standard position, PS, standard position means it's measured from the positive x-axis, okay? Passes through the point 12, 5. Find the value of the 6 trig functions. All right. All right, let me draw you a picture. Should you draw a picture every time? It's a good idea, especially if you're a visual person like me. But if you don't need the picture and you want to move forward, go for it. I'm going to go ahead and draw it right now, though. Okay? Here you go, Eduardo. Here we go. All right. Not going to be specific, but I'm going to say 12 is right here and 5 is the y, right? Okay. So when we draw the picture, that point is going to go through that point. So watch out. A lot of people connect the 5 and the 12 and say, that's my triangle. All right. Your triangle starts from the origin. So you start at 0, 0, hello, and draw the line that connects to that point. All right. So don't connect the intercepts. Draw the line that connects to that point. With me, William? Here we go. This is probably the biggest mistake that I've seen on tests and quizzes is drawing the wrong triangle. All right. So here we go. If you were to now drop it like it's hot. There you go. This is where your triangle is, and your angle theta, page is dying, is right there. All right. So we know that just from measuring distance, our y value is, hello, 5, thank you. And our x value is the 12. So we have our y, we have our x,
What is the third letter? R. So we have, okay, we have xy, we need to find r. Okay, so to find r, we can use that r squared equals x squared plus y squared, or you can use the simplified one. If you want to do the square root one, go for it. But this is like everyone knows the a squared plus b squared is c squared. So in this case, r squared is equal to 12 squared plus 5 squared. So 144 plus 25 is 169. Therefore, r has to be 13. I feel like we did this one earlier. Yes, we did. Yes, we did. Okay. All right. So if you want to find the 6 trig functions, all you need are x, y, and r. Ready? Here we go. Here we go. Here we go. All right. Let me hit the select and give myself a little bit more room. All right. So we have our 3 letters. Now let's find the first 3. What's the first one? Sine. Very good. Sine theta is going to be what over what? Yes, because it's the y over r. So that's 5 over the 13. It's really this easy. You're just basically plugging it in. Yeah. Okay. The cosine of theta is x over r. Therefore, 12, 13. Tan is what over what? Yes, because it's y over the x. Now take a look at what happens. If you set it up this way, can you sine first and cosine?
The answer for tangent is cancel out 13.
Okay, here we go. It's 5 over 12, right? Over 12. All right. Let's do the reciprocals. Let me change pens. Oh, I feel green. Here we go. What is the reciprocal of sine? Cosecant. Cosecant. So CSC is the abbreviation, right? The cosecant is just the flip. So yeah, r over y, which is 13 over 5. P.S. I'm writing everything down. You do not have to write everything down. You just give me the answer on your homework. But it's a good thing on your notes to go ahead and just like make sure you account for everything, right? Reciprocal of cosine. Secant. Yay. So that would be r over x, which is 13 over 12. Very good. And now cotangent is x over y. Cot. Oh, yes. 12 over 5. And this, my dear, is what they are asking for. All 6. I'm sorry, I just erased that. You need to have all 6 of them. Yes? Yes. Okay. Okay. Here we go. I think this is the next one has something to do with, nope, it's not that special. All right. Here we go. All right. I'm going to pause it right here. I want you to try this one. Okay, so I'm going to pause it.
What is it? No, it's the letter C.
Double check your picture. Does your picture look something like this?
Yes.
Yes.
Oh my God.
Right? I know. Did you connect the 6 and the 8? Because if you did, that's not where your triangle is. That's not it.
I did it the other way.
You did it the other way. Oh. Oh, yeah. Well, yeah, approximate 8 down 6. Ooh, change it. All right. Okay, so it helps to have a good picture. All right. If you did it correctly, you did the square root of 8 squared plus negative 6 squared, which was the square root of 100, right? Which is 10. It's 10. Right. All right. Here we go. 6 trig functions. Eddie, talk to me. Sine is Negative 6 over 10, which reduces down to? The back of the book will have reduced fractions, rationalized denominators, and simplified radicals. Yay? So reduce if you can. All right. So cosine is 8 over 10, which is 4 over 5. Gorgeous. And then tan is negative 6 over 8, which is negative 3 over 4. Yay? Okay, continuing our list. Here we go. Reciprocal of sine. Cosecant is 5 over negative 3. Very good. P.S. If in the back of the book, if they bring the negative to the front, that's okay. You can bring the negative out of the numerator and denominator and just put it in the front. Reciprocal of cosine. Secant. So that'll be, yes. And cotangent is the last one. 4 over negative 3. P.S. Why can't Edgardo buy a car?
Yeah, nobody did post.
All right, here we go. Thank you, Tony. Thank you. Okay, my dears. Yeah, I see you. Okay, I'm gonna keep.